Math 3 Lesson Summary Video. Did it make a difference? This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this lesson is to learn to use randomization to determine statistical significance. We did an experiment in class today where students took a little quiz with or without a calculator. It had a comparison control group, and students were randomly assigned the treatment. We did not have very sufficient numbers, but we did do the whole class. After the quiz, students determined that they did not think the calculator made any difference because the questions on the quiz were so hard and the numbers were so large that the calculator couldn't do anything with them anyway. Here is the data we collected. The mean of the calculator group was 3.5, and the mean of the no calculator group was 4.3. The no calculator group did better. The difference between the two groups was negative 0.8. Why was there a difference in the two averages if the calculator made no difference? Is this difference a significant difference? How could you even measure if it was significant? To find out, we ran a randomization test. This is where you take all the data outcomes and randomly assign them to one of the treatments. The idea behind it is we want to see if the difference between the treatments is rare, or if you get a similar outcome by just randomly throwing the numbers into groups. We followed this process to do it. Here were our results. To figure out where our actual difference from our experiment compares to these results, we made a frequency distribution. When we look at the results of our randomization, we are trying to compare where in the distribution our experiment difference would fall. If it is statistically significant, we would expect it to be an outlier, or somewhere in the outside 5%. This could be in the 2.5% at either end of the distribution. We find that our experiment difference on negative 0.8 falls near the middle at the 28th percentile. This would mean that the difference in outcomes could just as easily come about by random, so the treatment made no significant difference. Students in Miss Langston's class want to answer the following question. Can music help you perform better on a test? They randomly assigned 20 volunteers at their school to wear headphones, playing Mozart, or headphones playing no music. The subjects then completed a test. The scores on the test were recorded. The results are given below. The mean of the Mozart group is 81.5. and the mean of the no music group is 82.4. This is a difference of negative 0.9. But is this significant? As stated before, the best way to make this comparison is through a randomization. This can be a very tedious and time-consuming task if done by hand. Thankfully, there are several digital tools to help us with this task. The display shows 1,000 runs of randomly assigning the 20 test scores to either the Mozart or no music treatment. There are 423 results that are less than negative 0.9, putting it in the 42.3 percentile. There are also approximately 451 results that are greater than positive 0.9. This means there are 874 results that are more extreme than our original outcome, or 87.4%. There are two ways to think about this. In order to be significant, the percentile would have to be 2.5% or 97.5% to be in the outer 5%. You could also think about it as there are 87.4% of the results that are more extreme than ours, which is much more than 5%. Therefore, we can conclude it is quite plausible that the music does not affect the test score. In other words, a difference of negative 0.9 on the test would not be unusual if the music made no difference at all, and you randomly divided the subjects into two groups.